2.4b, the chain rule. Example 1, find dy dx when y equals sine 2x. So this is just, we're incorporating trigonometry with the chain rule from the previous section. So basically, I want to look at this function as y equals sine of u. So I am going to treat the 2x as my inner function. And then sine would be my outer function. So once again, the chain rule is the derivative of the outer times the derivative of the inner. So this is the inside function, and then sine would be the outside. So you treat this as sine u. Derive it, and the derivative of sine is cosine u, but because this is a function, I'm going to multiply it by the derivative of u. So u is 2x. Well, what is the derivative of that? 2. So our derivative, officially, is cosine of u, which is actually 2x, times du, which is 2. And there's our derivative. The only thing I would do is write the 2 in the front. So there you go. Now, whenever there's just basically a coefficient in front of the x, the pattern is that that coefficient ends up right in the front. So for example, if I have this equation, 3 sine of 2x, then it's basically 2 times 3. So 6. And then actually derive the trig function, and then that's it. Or let's say I have another example. Let me make, no, I want green. Okay. Let's say I have 4 cosine of 3x. So basically what's going to happen is, when I derive, oh, you know what? I never wrote, there you go. When I derive, it's going to be 3 times 4, which is 12. The derivative of cosine is negative sine, and then 3x is still there. Okay, example 2. Find the slope of the line tangent to the curve. Y equals cosine theta to the 5th power, or cosine to the 5th power of theta, whatever, at the point where theta is pi over 3. Okay, very quickly, unit circle. So pi over 3 is 60 degrees, right? So about right there. 60 degrees, pi over 3. Coordinates at 60 degrees here are 1/2 and the square root of 3 over 2. Okay, so find the slope. Slope in this class means derivative. Specifically, if I'm asking for the slope of the line that is tangent to this curve. Okay, the tangent line to this curve at this point, or any tangent on the curve at a certain point, is always going to have the same slope. So if I want to find the slope of the tangent, all I have to do is find the slope of the curve. So finding slope is deriving y prime. All right, before I find the derivative, I want to rewrite this. So I'm going to treat this as y equals cosine of theta to the 5th power. Okay, it's much easier if you just take the exponent and move it like outside of parentheses like this. It means the same thing. These are equivalent. Okay, so now that I have this, I'm going to treat this stuff as u. That'll be my inside function. So now what I actually have is u to the 5th. Okay, derive that. So then we come back over here. So y prime is going to be 5 times u to the 4th times du, right? The chain rule. Okay, so back over to the right side. So u is cosine of theta. Okay, what is du? Du is negative sine of theta. So now I'm going to plug that in here, and I'm going to plug it in here, right? Those two pieces go there. So y prime is 5 times u. Let's see what was u. Cosine theta to the fourth times du, which is negative sine theta. The only thing I would do is I would rewrite negative 5, right? The negative, bring it to the front, and then cosine to the fourth power, and then sine theta. And there you go. Example 3. An object moves along the x-axis so that its position at any time greater than or equal to 0 is given by x of t equals cosine of t squared plus 1. Find the velocity of the object as a function of t. Okay, so here's my position function. X of t is position. They want me to find the velocity of the object. Velocity is the first derivative. So all I have to do is derive this function. Okay, what I'm going to do is, I'm going to rewrite it. X of t is basically like cosine of u. Okay, so all of this is u. So now, let's see, u is the t squared plus 1. And I know I'm going to need du. So the derivative of that is 2t. Okay, so this is how I'm going to treat my function, and that's what I'm going to derive. The derivative is velocity. So the velocity of cosine, I'm sorry, the velocity of cosine. The derivative of cosine is negative sine u. Due to the fact that this is a chain rule, because this is a composite function, I'm going to have to multiply by the derivative of u, or the derivative of the inner function. I do have my pieces though, so it's not really a problem. So v of t is going to equal negative sine u is right here. So t squared plus 1 times du, which is right here, 2t. And then the only thing I would do is just rewrite this better. For example, the 2t should come to the front. So negative 2t, and then sine t squared plus 1. That's it. And this is the velocity of this function, basically for any t, any time. So this is just a general equation for my slope. Example 4. Find f prime of theta if f of theta is equal to sine cubed 4 theta, or sine of 4 theta cubed, whatever, same thing. So rewrite. Okay, this is actually a double chain rule because I have like a function inside a function inside a function. Okay, so basically this is how we're gonna unravel this. It's like nesting dolls. You gotta take the one that's out, take the outer one, open it up, and then pick out the doll that's inside, and then take that out and open it up and take out the doll that's inside that. If you don't know what nesting dolls are, look it up. Okay, so to start off, I'm going to treat f of theta as sine of 4 theta cubed. Okay, the exponent is the best thing to take out first. I'm not taking it out, I'm just kind of moving it outside these parentheses to help me be able to see clearer here. Okay, if I'm deriving, I'll do that on the right side this time. I'm going to derive this as u. So basically, what I have here is u cubed. Okay, that should be easy enough. Let's see. So u is the sine part with the 4 theta. Okay, so back to the right side. So derive u cubed. So I get 3u squared, but since this is a chain rule, I'm multiplying by the inner function, u. Okay, so u is sine 4 theta. So let's go back over here. Du would be the derivative of sine 4 theta. But sine 4 theta, although it is an easy chain rule to do, because it was the first example, and I said whenever you have a coefficient, what you just end up doing, but still. So sine 4 theta, we're going to treat that now as sine of, just pick a letter. I'm going to pick W. So sine of W. So then when I derive sine of W, right, in order to get du, it's cosine of W times dW, because this is another chain rule. So W, yeah, we have to go there. This is W, right? So W is 4 theta. Okay, what is dW? Oh, so let's put that all together. All right, so du is the cosine of W, which is 4 theta, times dW, which is 4. And as predicted, it's just the coefficient of the variable is basically getting multiplied in the front. So 4 cosine 4 theta. So this is my du. Okay, so u. Well, actually, let me erase this. Okay, so u is right here, and du, after doing all of the other extra chain rule, is 4 cosine 4 theta. So back to the right side. So I have 3 times u. U is sine 4 theta squared times du, which is 4 cosine 4 theta. And the only thing I would change is the 3 and the 4. This 3 and that 4 can be multiplied to 12. And then we just have to put the square back where it belongs, or the exponent. So sine squared 4 theta times cosine 4 theta. And there's my answer. Oops, it's supposed to be a dot for multiplication. Oh, okay, let's just return that. And let's just erase this part right there. 4 cosine theta. Forget the dot. Okay. Example 5. Find the derivative of g of t equals tangent of 5 minus sine t, sine 2t. Okay, so normally when we have trig functions, we see something like this. Sine of x, cosine of 3x, tangent of 5x, whatever. See this stuff, right, is what we're either going to take the sine of, or find the sine of, or the cosine of, or the tangent of. So notice how tangent doesn't have, you know, some little number next to it, because all of this is supposed to be this part. Okay, a lot of people get confused and they think that they see a tangent x and then some other function and they want to do product rule. And that's not the case here. Okay? What we have here is basically tangent, and then this is u. This is basically what we have. So tangent of u. Okay? So u is 5 minus sine 2t. Oh look, this is another composite function. Therefore, this is also a double chain rule. It's still simple to do. So du is the derivative of u. So the derivative of 5 is 0. And then minus, so the negative sine 2t part, I'm going to actually derive that. So let's see, the negative, it stays there. Now sine, what's the derivative of sine? It's cosine. And then this is the inner function. I'm trying to do this without having to write w. Okay, this is the inner function. So it's 2t, it stays the same, but then I have to multiply by the derivative of 2t. What's the derivative of 2t? It's 2. Okay, this really is a pattern. Whenever it's just a simple coefficient in front of t. Even if it were t squared, it'd still be easy to do, but it's just simpler or easier to see if it's just a coefficient. If it's just a number, basically you're going to take that number and multiply it in the front also. This stays the same though, and then the sine or the trig function does have to get derived. Okay. Um, so, oops, didn't mean to erase all of that. Okay, so I have my derivative. Oh, I'm just going crazy with the eraser here. Sorry. Okay, better. So I have my pieces. Actually, I don't really have the derivative. I have my pieces. So let's actually derive this. G prime of t. Okay, what's the derivative of tangent? So the derivative of tangent is secant squared u times du. Okay, whenever you are deriving composite functions, you have to multiply by the derivative of the inner function, and that is du. That is what du represents. Okay, we have our pieces, right? So hold on a second. All right, cleaned it up some. So we have our pieces. Here's u, right here. So secant squared of 5 minus sine 2t times du, and here's du, negative 2 cosine 2t. And then the only thing I would fix, or not fix, rewrite, is the negative 2 would come to the front. Coefficients, numbers, multiples, scalars, whatever you want to call them, they should always be written in the front. It's proper math notation. Doesn't make your answer wrong, it's just you're writing it correctly. And then the rest is whatever it is. Minus sine p times cosine 2t. That's it, right? This is this flew up here, and this stayed right there. Okay. Finito. Answer the practice problems, please.